This is week 9 and 10, CIS 1103 Internet layer and routing. Okay. The Internet layer protocols, they are used to deliver packets to specified network destination based on the IP address. Okay. And IP or Internet Protocol is the main Internet layer protocol. We have now IP version 4 and IP version 6. And they are used by routers to direct packets to their destination. Okay. So it is layer here. This is the layer 3 of the TCP IP. The IP version 4 address, we have already talked about this. It's 32-bit logical network address, also you can call it. And it is assigned to the network interface, such as workstation, server, IP phone. The router interfaces that provide connection to an IP network will also have an IP version 4 address, of course. And every packet sent over the internet, it should have a source address and destination IP version 4 address. It is 32-bit, and it is entered as dotted decimal. Okay, here we have an example, 192.168.1.5. If we convert it into binary, we will get this number. So this number here, 1, 2, 3, 4, 5, 6, 7, 8. This is the first octet. This is equivalent to what in decimal? 5. Okay. What about this one? So 1, 2, 3, yeah, here. 1, 2, 3, 4, 5, 6, 7, 8. And this is equal to 1. This is the second octet, okay? And this is equal to 168. And this one here, the last octet is equal to what? 128 plus 64, 192. Okay, you know now how we got this? Remember in the previous chapters, I show you how to convert. Okay, the 8-bit is equal to 128. The bit before it is 64. So if I have 1, 1, this is 128 plus 64, which is what? 192. Okay. We'll do some examples here about conversion. So here, if there is a 0, you don't add the value. If there is 1, then you add the value. So if I have this all ones, this is equal to what? 1 plus 2 plus 4 plus 8 plus, which is equal to 255. So 8 ones in binary is equal to 255. Okay. If I have this, then I need to convert it. This is 1 plus 2 plus 4 plus 32. Correct? Which is equal to 39. You have to know this. You will get questions how to convert. Okay. So please practice. Any questions here? Type 1, 1, 1, 1 is equal to what? 4 ones. 1 plus 2 plus 4 plus 8, which is 15. Okay? So this is the conversion. If you want to do it in the slowly, the step by step. Here you are going each, if there is a 1, then you count the value. You add the value. If there is 0, you don't add the value. Okay, so here I have 1, 2, but 0, so I don't add it. 4, I have 1, so I add it. So I have 1 plus 4 is equal to 5. Okay, everyone, please pay attention here, okay? This is important. Any questions? The network address is also, so the IP has 2 parts. One part is the network address. The other part is host ID. So if I have 172.16.30.256, this part is called host address, And this part is called network address or subnet address or subnet ID. Okay? Okay? Subnet mask, it is the value that allows the recipient of the IP packet to distinguish between the network ID portion and the host ID portion. We'll show you how. We use AND, logical AND. Okay, we AND the IP address with the subnet mask so that we can identify the network ID. They are logically ANDed, bit by bit. Let us see an example. So if I have here 192.168.10.10 and I have this subnet mask, okay, with this subnet mask, we said that if it's 1 plus 0 is what? 1 and 0, logical AND. Logical AND means like you multiply. I multiply 1 by 0, what's the answer? 0. 1 by 1, 1. So wherever there is 1, 1, I will put the 1. So here I will get this number. So what is my network address? This is my network address. And this is my host ID. This is my network address. The last octet is my network ID, which is 10. All right? So this is how, so we said that the IP address has two parts. One is network address ID, and the other one is host ID. How do I know the network ID? I bring the subnet mask and I do ANDing, logical ANDing, like multiplication. Wherever there is 1, 1, then you get 1. Other 1, 0, 0, 1, you will get 0. So here, once we do the logical ANDing, we get this number. This is my network ID, and the last octet will be my host ID. So what is my network ID here? 192.168.10. What is my host ID? 0.0.0.10. Okay? Very good. Now the IP version 4 address structure is been divided into classes. We have a class A. The class A is you can get up to 128 networks, okay, but a huge number of hosts, okay. So this is class A. Class B is the first two octets are for network, the last two octets are for host. Class C, the first 3 octets for network, the last octet for host. The total number of networks for a class C is here, 2 million. Plus. So a class A is this one. Starts from this to and ends with 127.0.0/8. Okay? And the first byte is assigned to the network address, and the 3 remaining bytes are used for the host address. So here, this is what a class A. Which part is the network address? Only the first octet, 10. For this one, what? Okay. The first bit is .1. The last bit is 255.255.254. Please, these are important examples. You have to practice by hand. I have this address. What is my host's range? And what is my broadcast? The broadcast is the last available ID. And if I put all ones, this is the broadcast. For a class B, this is my network. My host range is from 0.1 into 255.254. The broadcast is .255.255. class C /24. So when you see /24, meaning this is a class C. The first 3 octet are my network ID. Okay. The last octet is the host ID. The range is from .1 to .254, and the broadcast is .255. Very good. Okay. Okay, let me take the attendance, or let us finish this and then attendance, no problem. Okay, the IP version 4 structure. Here we can see that we have multiple networks on one physical network. But the network portion of the logical network host address is different. The host with the same network number will be able to communicate with each other. But if they are on different number or different subnet, they will not be able to communicate with each other unless there is routing. So here we have, look here please. We have one network here. What is the network ID here, please? Who can tell me on the left side? 192.168.18, صح? What about the one on the right, the green number? It's 192.168.5. These are two different networks. Okay. So here I have one physical network, but I have two digital or logical IP version 4 networks. Broadcast. Here the message is sent to all hosts on the network. Unicast, it is sent to a single destination host. Multicast, these are packets sent from a single source transmitted to many devices or multiple devices. Okay, so these are definitions. This is a multicast, this is unicast, and this is broadcast. The router will not allow broadcast to pass through the router. Okay, so it is a broadcast containment, or we call this a broadcast domain. Okay, this is a broadcast domain. All right, and this is a broadcast domain. Okay, routers in the distribution layer can limit broadcast to the local networks. Okay, so which is very important. For security also, routers in the distribution layer can separate and protect certain groups of computers where confidential information resides. Routers can also hide the addresses of internal computers from the outside world to help prevent packets and control who can get into or out of the local network. Okay? So why we need routers? Routers in the distribution layer can be used to interconnect local networks at different locations. For logical grouping also, routers in the distribution layer can be used to logically group users. Yani such as if I have finance users, they can be grouped into one router or one group. Okay. So you can see here, we have router, we have engineering, then we have accounting. Okay. So they are all connected to the distribution. We learned before that in the data link layer or network access layer, a switch uses what? MAC address or IP address? Who remember? The switch. Please, Shabab. MAC address. The switch uses MAC address. The router uses the IP address to forward the packet. Okay. So here we have a message. This is the destination MAC. This is the source MAC, source IP, destination IP. The router will check these two numbers. And then the router will choose the best path to forward the packet. Okay, so here we have an example. For this router, we have a routing table. The routing table have the rules for the router to use when it forwards a packet. Okay, so the router will receive the packet. It will check its routing table. The router has in its routing table that if you want to go to network 10.0.0.0, then you forward the packet to FA0/0 here. And if you want to send a packet to this network, then forward the packet to FA0/1. Okay. Routers block broadcast. They do not forward broadcast message. So here, if the router receive a broadcast, it will not forward the message. Okay. So look here, if A1 is sending a message, okay, if H1 is sending, please watch carefully. If H1 is sending to H3, the router will forward it. It will not go to the router. Why? Because they are in the same network. They are all local network. If H1 is trying to send to H4, it will need to go through the router. And the router will decide where to send it. Understood? Based on what? The router will use the IP address. The switch will choose the MAC address. Very good. The routing table has different entries. It contains network addresses and the best path to reach a network, as I mentioned. And you can add routes in two ways, either dynamically, it learned it from other routers, or manually, you enter it as an administrator. We have also a default route is the router interface used when forwarding packets to a destination that is not in the routing table. If a packet is distant for a network that is not in the routing table and no default route exists, the packet will be dropped. So these are the rules. Don't forget them. Please answer my question here. If a packet is distant to the network H.1 or H.0.0.0, it will be forwarded to which interface on the router? If its destination is 10.0.0.0, which port it will be sent to? Fast Ethernet 0/0. Yani this is the door to this network. If you are sending a packet to network 172.16.0.0, which port you will use? Fast Ethernet 0/0. لأنه هي موجود بالجدول صح؟ Okay, very good. Any questions? The default gateway, when a host sends a message to a device on the same network, it forwards the message directly and uses ARP to discover the MAC address. But if you are sending to a remote network, the host uses the MAC address of the router as the destination, but the IP address will not change. I already explained this to you. And you have to make sure that each device have the correct gateway so that they can reach to the router. Okay? We will do this in the lab. Static and dynamic addressing for your computer. You can assign your IP address to the computer here. If you are typing everything, this is called static. You are entering it manually. There is another option, okay, to use dynamic, and to use DHCP, dynamic host protocol, okay, dynamic host configuration protocol. It will save us time, and we will not make, it will make it easy for less effort for the administrator to avoid errors, so that you don't give the two computers the same IP address. So these are all advantages of using dynamic. Okay. Any questions? Thank you very much.